All right, today we are diving into something that is completely rewiring the AI world from the ground up. It's called the Model Context Protocol, or MCP for short, and it's basically creating a universal language so AIs can finally talk to the outside world and to each other. Now, to really get why that's such a massive game changer, we first have to understand the absolute mess it was designed to fix.
So let's start there. Let's talk about what I like to call the AI integration nightmare. This is the core problem that MCP was built to solve.
So why is this even a thing? I mean, large language models are brilliant, right? But their knowledge is kind of locked in the past based on their training data. For them to do anything useful for you right now, like check today's weather or save a file to your desktop, they need to connect to external tools. And for developers, trying to build those connections has been, well, a total nightmare.
I want you to just imagine this for a second. Imagine every time you met someone new, you had to learn an entirely different language just to have a conversation. You meet one person, you have to learn French, the next, German, the next, Mandarin. It would be exhausting, right? You'd spend all your time learning how to say hello instead of actually communicating. Well, that's pretty much exactly what AI developers have been up against.
This whole situation has a name. It's called the M times N integration problem. Sounds a little technical, but it's simple. If you have M number of AI apps and you want them to use N number of tools, you have to write M times N custom integrations. You have 10 apps and 10 tools? That's not 20 connections, it's 100. It's a combinatorial explosion of work that just completely falls apart at scale.
So before MCP, what you ended up with was this digital spaghetti monster, a tangled web where every single app was hardwired to every single tool it needed to use. The code was brittle, a pain to maintain, and it just massively slowed down any real innovation.
So how do you fix a tangled mess like that? You go right back to our language analogy. You don't learn 100 different languages. You invent a universal translator. And for the world of AI, that universal translator is MCP.
And just like that, with MCP, that M times N nightmare becomes this beautiful, elegant M plus N solution. Suddenly, every AI app only needs to learn how to speak one language, MCP. And every toolmaker just has to do the same. Any app can now talk to any tool instantly with no custom code. It is such a simple fix for such a deeply complex problem.
So what is MCP, officially? Well, think of it as a standardized rulebook, an interface that lets AI models connect with the outside world. It's the common ground, that shared handshake protocol between AIs and tools that, honestly, we've desperately needed for a while now.
Okay, if you only remember one thing from this whole explainer, please make it this analogy. MCP is to AI what USB-C is to all your gadgets. You remember that junk drawer full of a dozen different chargers? Now, one single port, USB-C, connects almost everything. MCP is doing that exact same thing, but for AI tools and applications. It is the universal connector. Okay, so it sounds great, it sounds revolutionary, but how does the magic actually happen? Let's quickly peek under the hood and see how this thing is put together.
It's actually a pretty classic setup with three main players. First, you have the host. That's the app you're actually looking at, like a chatbot or a code editor. Buried inside the host is the client. That's the little messenger that actually speaks MCP. And finally, you've got the server, which is the external program that's offering up its tools and services for the AI to use.
An MCP server can offer up three core things. First, you've got tools. These are actions the AI model itself can choose to use, like calling an API to get data. Then there are resources. Think of these as read-only things, like a document or a database that the main app controls access to. And finally, you have prompts. These are pre-made templates that you, the user, can pick to guide the AI on a specific task.
All right, this is where it gets really, really exciting. The theory is one thing, but what does this actually unlock in the real world? Let's look at some absolutely incredible projects that are already being built on MCP.
First up is a concept that sounds like it's straight out of science fiction, giving two completely separate AI applications a single, shared brain.
So, you've got two powerhouse apps here. Claude Desktop, which is amazing for brainstorming and analysis, and Cursor, which is an incredible AI-powered code editor. Normally, these two live in totally separate universes. What you talk about in Claude has zero effect on what you do in Cursor. They're two different brains.
But with MCP, this all changes. Watch this. As you're chatting with Claude, an MCP server is quietly storing the key facts from your conversation in a shared memory.
Then, you hop over to the Cursor IDE to start coding, and bam! Cursor connects to that very same server, instantly pulls in all the context from your Claude conversation, and uses it to help you write way better, more relevant code. It's true interoperability in action, and it's amazing.
Okay, let's look at another powerful example. What if you could just ask an AI in a simple chat window to perform some pretty complex financial analysis and have it hand you back a chart?
With MCP, this becomes shockingly straightforward. A user makes a simple request. Behind the scenes, that kicks off a whole crew of specialized AI agents. One agent figures out the request, another writes the Python code to get the stock data, and the third one verifies and securely executes that code using an MCP tool. And the final output? A perfect stock analysis chart generated on the fly. It's complex teamwork made possible by a simple, standard protocol.
So as you can see from these examples, MCP isn't just some clever bit of code for developers. This represents a foundational shift, a whole new layer for how we build with AI.
So let's just recap why this matters so much. First, you get radical scalability. That M+N model means adding a new tool is simple, not a months-long project. Second, you get true interoperability. Apps can finally share a brain and work together, like we saw. And third, and this might be the most important one, this accelerates innovation. Developers can finally stop wasting time on plumbing and can instead focus their energy on building the next amazing AI capability.
And that brings us to the final thought I really want to leave you with. When you create a universal standard like this, you're not just making things easier, you're removing a fundamental barrier to progress. So if any AI can now frictionlessly connect to and use any tool, what incredible things are we going to build next? I, for one, cannot wait to see.